Let S equal to this set, then which of the following statement is are true? S is closed, S is not open, S is connected, and 0 is the limit point of S. This set S is given by 1 upon 3 raised to the power n plus 1 upon 7 raised to the power m, and mn are coming from natural number. So a point, suppose this is point A, said to be a limit point. If there exists a sequence, having the limit, or have the limit as point A. So if 0 is the limit point of this set, then there exists a sequence xn, suppose I call xn, such that limit of xn is 0. So we know that, consider yn is as 1 upon 3 raised to the power capital N plus 1 upon 7 raised to the power capital N, and n is greater than with mn. So this is, consider this is xn, and this is subsequence of set S. This is a subsequence of set S, or Sn you can say, because S contains subsequences, and limit of this is, as this is going to 0 and this is going to 0 when n tending to infinity. So limit of xn is 0, so 0 is the limit point of S. So option D is correct. Now check S is closed, open, or connected. Because this is these are points as S is given by 1 upon 3 raised to the power n plus 1 upon 7 raised to the power m. If it is an interval, then this is connected, because we know that interval of real line is always connected, either closed interval or open or semi-closed, semi-open, always connected. So 1 upon 3 plus 1 upon 7 when n equal to m equal to 1. This is 10 upon 21. So epsilon neighborhood of this means 10 upon 21 minus epsilon. This neighborhood contains some points of S complement. So this is not open, because the definition of open set is every neighborhood of point of the set is always inside the set. So it is not open by negation, not closed, because 0, as we find that 0 is limit point and which is not in set S. So this point is also saying this is not closed. And so S is closed, this option is false. S is not open, this is true. Now come to the point, S is connected or not, because 10 upon 21 epsilon neighborhood of 10 upon 21, write epsilon here. So epsilon neighborhood of 10 upon 21 is not in S, means this is not open, and we are checking it is connected or not, because this set is not in the form of, because I discussed this point very clearly. S is 1 upon 3 raised to the power n plus 1 upon 1 upon 7 raised to the power n. This is set S, and we are checking connectedness. So it means that we need to prove it is not a interval. It is not a interval, as this is going to 0 and this is also going to 0, but 0 is not there, so put 0 at open, and always this is never be 1. So, and this set is not containing 10 upon 21. This set is not containing 10 upon 21, and 10 upon 21 is less than 1. So it is not interval. It is not an interval, because upper bound is 1 and lower bound is 0. Lower bound of this set is 0. So if it is an interval of the type either closed or open, so it may be either this type 0 1 if it is closed, or if it is open then 0 1, but both interval not containing 10 upon 21, so it is not interval, so not connected. So option C is also discard here. Let Sn be a sequence of real number given by this expression, then the least upper bound of the sequence Sn is, so Sn is 2 raised to the power minus 1 raised to the power n, 1 minus 1 upon n sine n pi by 2. This is given by Sn, and sine is involved here. So what is the graph of sine x? This is the graph of sine x. This is pi by 2. This is 2 pi by 2. This is 3 pi by 2. This is 4 pi by 2. This is 5 pi by 2. This is 6. This is 7, 8, 9, and 10. So you can check, this is 2, this is 4, this is 6, this is 8. So even multiple of pi by 2, value of sine n pi by 2 will be 0. So second term will be 0, fourth term is 0, and sixth term is 0. Now find first term. As putting value of n is 1, this is 2 raised to the power minus 1, and inside the bracket 1 minus 1, 1 upon n is 1 here, and sine pi by 2 is 90. So this is first term, this is second term. So third term will be 2 raised to the power minus 1, 1 minus 1 upon 3, and sine 3 pi by 2. Value of sine 3 pi by 2 is minus, so negative appears here. Value of fourth term is 0. Value of fifth term will be 2 raised to the power minus 1, 1 minus 1 upon 5 sine 5 pi by 2 is 1. So this is this value, so 0 and so on. So we have find the value of terms. These are terms of sequence. So this is 1 upon 2, 1 minus 1. So first term is 0, second term is 0, third term is minus 1 upon 2 minus 1 upon 3, 0 again 1 upon 2, 1 minus 1 upon 5, 0 and so on. So as 1 minus 1 upon n involved in the sequence, so after the some time limit of this one will be 1. So value of sum term will be 1 minus 1, 1 upon 2 into this into value of sine is 1, and sometimes value will be 1 upon 2 negative of it. So max value, as you can see, this is half, this is max value, max of all terms, max of all term is half, it means 0.5, and min of all terms, because some terms are negative and other less than multiple also there, so min term is minus half. So what is asked about least upper bound. So least upper bound, because this is max value, so it will be work as a least upper bound. So least upper bound is 0.5. Let Sk be the sequence of real number where Sk is defined by this expression, then limit of this expression is. So to find limit of n tends to infinity, S1, S2, these are the product of terms of Sk, S3 and so on up to Sn raised to the power 1 upon n is equal to limit of Sk, which are used here to write terms of the product. So this one equal to limit of Sk, and we use this concept by Cauchy second theorem. Cauchy second theorem on limit. Theorem on limit. We use this fact that says if Sn is a sequence of real number that converges to a real number L, then limit of S1, S2 and so on Sn raised to the power 1 upon n is also is equal to 1. So used this Cauchy second theorem on limit. So this one equal to limit n tends to infinity and Sk is k raised to the power alpha raised to the power, because n used here, either you can write n or k, so as k, so k tends to infinity alpha upon k, and use the fact limit of n tends to infinity n upon n raised to the power 1 upon n is equal to 1. So use this here, limit n tends to infinity k raised to the power 1 upon k raised to the power alpha, because alpha is greater than 0. So limit of this one is also 1. So 1 raised to the power alpha is 1. So limit of this equal to 1. Let x equal to this column vector, which is belonging to R cube, be a non-zero vector, and let A equal to x transpose divided by x transpose x, then the dimension of the vector space this over R is. First, you may get confused as matrix A is defined as x transpose upon x transpose x, because division in matrix division in matrix is not defined. Then what is this? If x is this column vector x1 x2 x3, then its transpose will be x1 x2 x3. Now take product of these two matrices, because this is 3 by 1 and this is 1 by 3. So product, these two matrices are compatible for product, and resultant will be 3 by 3 matrix. So after multiplying this means x transpose, we will get x1 square first row with first column, x1 x2 x1 x3 x1 x2. Now this is x2, so x2 x1, it is perfect, x1 x2 x2 square, and this will be x2 x3 x1 x3 x2 x3 and x3 square. In diagonal entries you can check, this is x1 square x2 square and x3 square. Now this is x transpose, as these x1 x2 and x3 are coming from real set, so x transpose x, what is it? It is x1 x2 x3 and x is x1 x2 x3. So resultant will be x1 square plus x2 square plus x3 square. This is matrix and this is 1 by 1 matrix. So this is a number, this is a real number. We can, if I write 0 in this matrix, 0 in this format, then its simple meaning is 0. 0 is a real number, so this is a real number. So you can divide matrix by this real number, means all elements divided by this real number. So now matrix A is suitable as given, and we have to find dimension of this set. Suppose this set is S, I call, or W you can say, y belongs to R cube such that AY equal to 0, means all those solution, if we find matrix representation of AY equal to 0, then we have always solution. Mean consistent, this system is consistent and have solution. So this is null space, this is nothing null space. So we have to find dimension of null space, means nullity. As this is a single constraint, so dimension will be, because this is from R3, so 3 variable used, 3 minus number of constraint is 1, so 2 is the dimension of null space, or 2 is nullity. You can find directly, or as we have to find dimension of this is second method. You can understand AY equal to 0, and matrix A is x1 square x1 x2 x1 x3 x2 x1 x2 x2 square x2 x3 x3 x1 x3 x2 and x3 square. This is, and we should to divide by this number, as number was x1 square plus x2 square plus x3 square. So we have to find dimension of ay equal to 0, because this is the number. So we have to find dimension of only this matrix, because dimension doesn't alter when we multiply or divide by a specific number. Dimension of null space. So find dimension of this matrix. Dimension of ay equal to 0 means only find dimension of, so suppose call this is a x, so ay equal to 0. Now we have to find dimension of this set, another set, you can say S. So dimension of this one you can find by reducing it in reduced echelon form. Now row reduced in echelon form, we need to apply some elementary row operation, because you have to make 0 under first position to make this is 0 and this is 0. So R2 by R2 minus x2 upon x1, this is a number with R1. Now apply this, and second R3, how R3 you need to change, R3 minus x3 divided by x1 R1. So you need to apply this to a elementary row operation, and you will get x1 square x1 x2 x1 x3 0 0 0 0 0 0. So now you can check that you have two free variables here, because this is pivot position, this is basic variable. So one is basic variable and two are free variables. So dimension of ay equal to 0, dimension of this set is 2. So 2 is correct answer of this problem. Let f be a real valued function defined by f of xy equal to 2 log x square y square e raised to the power y upon x, and xy are positive. Then the value of x partial derivative of f with respect to x plus y partial derivative of f with respect to y at any point xy where xy are positive is. So first simple method, you can do partial derivative of this function with respect to x and y and directly put the values of in this expression and you will get the answer. But this is not advanced method or to solve this problem, as the purpose of the asked this problem is to find you have problem solving skill or not. As f is a function, xy is given to us 2 log of x square y square e raised to the power y upon x, where x and y are positive. Now write this function. As f is given, write this function in terms of another function called u. Then we can write log x square y square e raised to the power y upon x u upon 2. Now to remove log or logarithm here, you can take x square y square e raised to the power y upon x equal to e raised to the power u upon 2. Now call here, this is another function. We actually, our motive is we are doing to write this function f as x raised to the power n and function of y upon x, means homogeneous function with a degree. with some degree, as n is the degree we normally know. So we are going to write in terms of y upon x. So we are doing some manipulation, you can see here. So this is another function, we call it v. So v can be written as x square y square e raised to the power y upon x. Now you can write this is x raised to the power 4 y square upon x square, and this is e raised to the power y upon x. Now this and this are in terms of y upon x. So you can say this is function of another function, you can say g x raised to the power 4, and g is the function of y upon x. So 4 is the degree of this homogeneous equation. So by Euler theorem we have x, because this is the function in terms of function of v, this is the function v. So partial derivative of v with respect to x and y. So partial derivative of v with respect to x plus y, partial derivative of v with respect to y, equal to degree of this function, homogeneous function, as 4 is the degree and this is v. So this is by Euler theorem. We used Euler theorem here, but we have to answer this question in original function f, in terms of f. So we are going to change the variable here. So x, as you can see here, this v is nothing but e raised to the power u by 2. This v is nothing but v was u e raised to the power u by 2. So partial derivative of this one will be, means partial derivative of v with respect to x will be e raised to the power u by 2, and take derivative of this is 1 upon 2, and partial u with respect to x. So put this value 1 upon 2 e raised to the power u by 2, partial derivative of u with respect to x. Now similarly, partial derivative of v with respect to y will be y into 1 upon 2 e raised to the power u by 2, partial derivative of u with respect to y, equal to 4 e raised to the power. Now change this v as, now this equation in terms of function u and its partial derivative. So e raised to the power u by 2 is here in this term also, and this is also, so we can divide throughout. So x, partial derivative of u with respect to x, plus y, partial derivative of u with respect to y, is equal to 4, and 1 upon 2 we take also common, so this is 2, so we got 8. And this u was f of u is this function, so you can write u or f. So x, partial derivative of f, in place of u you can write f with respect to x, plus y, partial derivative of f with respect to y, equal to 8. Now 8 is the solution, or 8 is the value of this expression as asked at any point xy, because we have no restriction over x and y. Let f is a function defined by root x I hat plus x plus y cube j hat, where vector field for all x y with x greater than equal to 0, and r is a position vector. Then the value of the line integral this from 0 0 to 1 1 along the path as c is defined the path. This path is parameterized by these equations in terms of t. as a function is given and position vector, and we have to find line integral. F is root x I hat plus x plus y cube j hat, and position function r is given as x I hat plus y j hat. So dr vector will be dx I hat plus dy j hat. So this line integral f will be along the curve C root x dx plus y cube dy. Let, or as given, x parameterized by t square and y is by t cube, and limits of t is means t is varying from 0 to 1. So dx equal to 2t dt and dy equal to 3t square dt. So these are partial derivative. Now put these value in the equation this. So this equation can be written as, because curve C is parameterized by xy and x by curve xy, curve C, and C is parameterized by in terms of t. So limit of t is 0 to 1, and this will be 2t square dt plus t square plus t raised to the power 9 3t square dt. Now you can take dt once and integral sign only once time. So you can write 2t square plus 3 t raised to the power 4, means you have applied distributive property here, plus 3 t raised to the power 11. This is integrand function and integral with respect to t. Now take integral, it will be 2t cube upon 3 plus 3 t raised to the power 5 upon 5 plus 3 t raised to the power 12 upon 12, and lower and upper limits are 0 to 1 respectively. Now put the lower and upper limits. We have 2 upon 3 plus 3 upon 5 plus 1 upon 4, as 3 4 is 12, and when you put the lower limit is 0, you will get the same. Now take LCM of this one. So LCM will be 60. So 40 plus 35 plus 15. It means 35 plus 15, 50. This is 90. 90 upon 60, 0 by 0. And 3 2 is 6 and 3 3 is 9. So 3 by 2 means 1.5, means 1.5. So we have to answer this question in decimal. So 1.50 up to 2 decimal place. Let f is a function defined on open interval -1 to infinity to r, and function is this, expressed as this format, where xi, as used in this last term, lies between 2 and x. Then the value of c, that c is also used in this term. We have to find the value of c. As function is given by this structure x upon 1 plus x, and this function can be expressed 2 upon 3, 1 upon 9, x minus 2 plus c, x minus 2 is square upon 1 plus xi cube. So you can see these types of format we obtained when we apply Taylor's theorem on the function around a certain point. And you can see, as I used here, this is remainder terms. If we say we applied Lagrange form of remainder up to 3 terms, means Taylor's up over Taylor's theorem. So for Taylor's theorem, we first keep remembering we can express any function in the form of polynomial structure. So this function, for that to apply Taylor's theorem, we need function should be many times differentiable. On saying this, we cannot say function is many times differentiable, but you can say if numerator and denominator is given, so you can apply quotient formula for differentiation, and you can say this is many times differentiable. Otherwise, you can write this function as 1 minus 1 upon 1 plus x, or 1 minus 1 plus x raised to the power minus 1, and you can apply binomial theorem here. So you can see this function is many times differentiable. Now use Taylor's theorem around a point 2. So fx can be expressed as f2 plus f prime 2x minus 2 upon 1 factorial, and this is remainder term f double prime xi x minus 2 square upon 2 factorial. So you need to value of f2, f dash 2, and f double prime xi. As function fx is 1 minus 1 plus x raised to the power minus 1, so you can f2 will be 1 minus, or simply you can say 2 upon 3. Value of f2 is 2 upon 3 plus f dash 2. So value of f dash x will be minus 1 to negative. So minus minus turns to positive. So 1 plus x raised to the power minus 2. This is f dash, and the value of f dash at 2 will be means 3 raised to the power minus 2 means 1 upon 9. So I can write 1 upon 9 here, and 1 factorial is 1. So x minus 2 f double prime xi. This is first derivative. So second derivative of the function will be minus 2 1 plus x raised to the power minus cube. So this is 2 factorial is same as 1 upon 2. So f double prime xi will be minus 2 upon 1 plus xi raised to the power 3, because of in denominator. So I can write minus 2 upon 1 plus xi raised to the power 3, and this is x minus 2 square. Now compare this function as given. So this is given format as I arrowed here. So this is 2 upon, I write a function again so you can see clearly. This is fx, which is expressible f2, 2 upon 3 plus 1 upon 9 x minus 2, and this is cancel out, so minus x minus 2 square upon 1 plus xi cube. So we obtained this format on applying Taylor's theorem, and the structure as given was fx is equal to 2 upon 3 plus 1 upon 9 x minus 2 plus c x minus 2 square upon 1 plus xi cube, where xi lies between 2 and x. So on compare, you can see value of c is minus 1. So value of c is minus 1 as used in this expressible form. So minus 1 is correct answer.